In 2003, researchers at a primate lab in Georgia sat two capuchin monkeys side by side and handed each one a small token, which the monkey could trade back for a piece of food. Both monkeys handed over their token. Both got a slice of cucumber. Both ate it without complaint. Then the researchers changed one thing. This time, when the second monkey handed over her token, she got a grape instead of cucumber. To a monkey, a grape is basically candy compared to cucumber. The first monkey watched this happen, looked down at her own cucumber, and threw it back at the researcher. She rattled the bars of her enclosure. She refused to trade her token again. She would not touch the cucumber for the rest of the session. That clip has since been watched millions of times online, usually captioned with some version of the same idea. Even monkeys know when they are being treated unfairly. So here is a question worth sitting with for a second. Do animals actually have a sense of fairness, or have we all just been reading our own feelings into a very good video? Humans have argued about this for a very long time, long before anyone had a camera to film it. Aristotle wrote that animals could never have a true sense of justice because justice requires speech, and speech is what lets beings negotiate what they owe each other. That was over 2,000 years ago, and the debate never really closed. It just moved from philosophy books into laboratories. If you have ever watched a 4-year-old protest that their sibling got a bigger slice of cake, you have seen how early this shows up in us. Kids that young will pay a real cost, giving up their own treat entirely, just to stop someone else from getting more than they did. Psychologists call this inequity aversion. It is not simply wanting more for yourself. It is specifically disliking an unequal split, even one that costs you something to reject. It shows up in almost every human culture ever studied, which is exactly why researchers started asking whether it might be older than humans themselves. If other animals show the same reaction, that suggests fairness is a deep evolutionary tool, something that evolved to hold cooperation together long before our species existed. If they do not, then something happened specifically in human evolution, something that pushed us toward tracking fairness in a way most of the animal kingdom never needed to. Cooperation is not free. Anytime two animals team up, hunting together, grooming each other, sharing food, somebody has to decide how the payoff gets split. In most species, that split gets decided by raw dominance. The strongest or highest-ranking animal simply takes more, and nobody protests, because protesting a dominant animal can get you hurt. Humans mostly do not work that way, at least not entirely. We built entire economies, legal systems, and everyday social rules around the idea that a fair split matters, even between total strangers. So scientists wanted to know exactly where that instinct came from, and the capuchin video looked, at first glance, like a real clue. After that 2003 study came out, dozens of labs around the world tried the same basic setup on their own animals. Crows and other corvids were tested. So were parrots, mice, rats, dogs, marmosets, and tamarins, along with several more studies on chimpanzees. Some of those studies found the same protest behavior. Others, using nearly identical setups, found nothing at all. A dog might refuse to keep obeying a command once it sees another dog get a better treat for the same trick. A chimpanzee might not react at all under almost the same conditions. For a while, that was treated as evidence that some species have this sense of fairness, and others simply do not. But there was a competing explanation sitting right underneath the whole field, and it was almost never fully ruled out. What if the animal is not upset about fairness at all? What if it is simply disappointed because it just watched a better reward appear and then did not get it? Think about it from the monkey's side for a second. She sees a grape. Grapes are wonderful. Then she gets cucumber instead. Of course that feels bad. whether or not anyone else is involved. Researchers call this the disappointment hypothesis, sometimes described as an individual contrast effect, and it does not require any concept of fairness whatsoever. It only requires noticing that something better was available and you did not get it, which is a much simpler mental trick than tracking what a completely different animal received. The trouble is that almost every classic experiment, including the original Capuchin study, showed the better reward to a partner sitting right there. That means a real sense of fairness and simple disappointment were tangled together from the very first version of the test, and nobody had cleanly separated them. You would need a huge amount of data, gathered the same way across many species, to finally tell the two explanations apart. One or two labs could never do that on their own. It would take convincing dozens of researchers around the world to open up their old raw data and hand it over. That is a much harder ask than it sounds. Raw data from old experiments gets lost, sits on outdated hard drives, or simply never gets requested in the first place. Which is exactly the gap a new team of researchers set out to close, not with one more monkey experiment, but by going back to every study anyone could still find. This mattered for another reason too. Psychology, as a field, had spent the previous decade going through a serious reckoning. Study after study, once considered classic and settled, failed to replicate when other labs tried to repeat them under stricter conditions. So a famous, emotionally striking result like the cucumber and grape video was exactly the kind of finding that needed a harder, more rigorous second look. So what actually happened when scientists tried to settle this properly, once and for all? A team decided the only honest way to answer it was to stop trusting any single study, including the famous one, and instead pool the actual raw data from every experiment they could track down. They ended up contacting the original authors of 30 separate studies, spanning 2 decades of research on this exact question. Getting that many labs to hand over their raw, trial-by-trial data almost never happens in this field. It is one of the largest efforts of its kind ever attempted on animal behavior. And once you gather that much raw data from that many species, you stop asking whether one clip proves something, and you start asking what tens of thousands of individual trials actually show. Which raises the real question everyone in this field wanted answered. When you strip away the anecdote and look only at the numbers, does the fairness instinct survive, or does it disappear? 23 of those 30 labs came through with usable data, covering 18 different species, 302 individual animals, and 60,430 separate observations. Instead of just averaging what each paper had already concluded, which is how older reviews of this topic worked, the team rebuilt every single dataset from scratch and ran the exact same statistical model across all of it. They specifically built separate checks for chimpanzees alone and capuchin monkeys alone, since those 2 species had been tested more than any others. 3 questions guided the whole analysis. Did animals reject more often when a partner got a better reward? Did they reject more often whenever a better reward was simply shown to them? And once you control for disappointment, was there anything left over that looked like fairness? Across the full dataset, animals were not significantly more likely to reject their reward just because a partner received something better. That held true across every subgroup the team tested. All 18 species combined. Just the species previously reported to show the effect. Just primates. Just chimpanzees alone. Just capuchin monkeys alone. The closest any result came to statistical significance was in the full combined dataset, and even there it fell short of the standard scientists require before calling something a real effect. Every other subgroup came back clearly negative. No hint of error in chimpanzees. No hint of it in capuchins, the very species that started this whole line of research. But the disappointment explanation told a completely different story. That effect was real and statistically solid. Animals rejected the lower value reward more often whenever a better one was visibly presented to them, whether or not a partner ever got it. Simply dangling a grape in front of an animal before handing over cucumber was enough to trigger a protest, even with 0 other animals anywhere nearby. And when the team isolated inequity from disappointment directly, testing only cases where a better reward had already been shown, adding a partner into the mix did not raise rejection rates any further. In other words, once you account for simple disappointment, there is nothing statistically left over that looks like a dedicated sense of fairness in these animals. The researchers are careful about what this does and does not prove. 7 of the original 30 eligible studies never sent back usable data, so the picture is not perfectly complete. It is also possible that some species feel this in more natural settings that a lab token exchange simply cannot capture, or that specific individuals with unusual personalities or long social histories react differently. What the data does undercut is something bigger. The idea that a fully formed sense of fairness, the kind that makes a 4-year-old refuse a smaller slice of cake purely on principle, is something humans simply inherited from a shared animal ancestor. Instead, that instinct may be something closer to a uniquely human invention, one that showed up specifically because our species leaned so heavily on cooperating with total strangers, not just close relatives. So next time that cucumber and grape video shows up on your feed, it is still one of the most watched clips in animal behavior research. It is just probably not proof of what most people think it is.